All right. So going here, we're on B5 extension, I guess, notes. I don't know. We had a real hard time figuring out what to name our chapters and all this. So, all right, but input, say it. That's what I was waiting for. And that's what graphing is. So where are the outputs less than zero? The graph that where the graph is, but below the x-axis. So that's what I would highlight first for this first. What am I doing? Sorry. Below, made a mistake there. Oh, and then equal to zero. Maybe really hit those. Maybe I had a bad choice on those are included. So that tells me I have to do something there. Okay, so those are zeros. So what that means, input, say it. When I input one into whatever p of x is as an equation, I will get zero. Zero equals zero. When I plug in -3, I get a negative. I plug in -3, a negative number is less than zero. All of these make the inequality true. So the solution set to make this true is these x's. Those x's from there to there, from there to there, and then all of the zeros. So that means I need parentheses or brackets. 3, 2, 1, go. Brackets. I had some people in my regular that cannot figure out to get a bracket or parentheses still. We keep spinning in our wheels in that class. It better not happen in here. I just don't know what I can do to get these things memorized so we can move on. Some people are stuck in August still, right? Some people are stuck 2 years ago in that class. They don't know how to factor. That's from freshman year. All right, so we got to get this taken care of. I'm just talking out loud because I'm starting to go crazy with that class. All right, and then of course, these are greater than values for y. That's what p of x stands. Those are the y values that are greater than. But what are the x's that create that? These. Maybe I'll change colors here. We'll go blue. Sticks out more than red. So those x's, and those x's, not including the zeros. So that's parentheses. 0 to 1. Oh, yeah, I got to exclude 1. Sorry, stick a union in there. And then 1 to infinity. That just excludes 1. That's the only way you could show that. Excluding 1 using interval notation. All right? All right. I should actually show you like the inequality answers for that because AP goes back and forth between interval notation and inequality. You got to be able to be ready for both. It is true. Okay, so then what's happening with this? What do I have to do? Why did I do the Bellworth quizzes? It's because we got to remember from last year, and actually I think we did a little bit this year as well, but we got to remember what the expectation of picture is. So first of all, what is it going to be? An x to the what? What if I multiplied this out? What's the answer? 3, 2, 1, go. 4. What's the leading coefficient going to be? It is 2, but that's still okay. It means we're going to do this for the polynomial dance. 1, 2, 3, 4. But it's this one. Okay. Maybe in the video when I do this is a positive x. Do I get mirrored though? Does that look like a negative on the video? I don't know. Does it look right on the video? At home. I just hope I don't get reflected and that looks wrong. So my zeros are 1/2 and 3. Don't be a fool. Put 1/2 and 3 in the correct positions on the number line. 1/2 is smaller than 3. And then I'm going to do a graph. 1/2 is a regular 0 and it's supposed to go through like that. And then 3, you're going to have to know this anyway, flattens out and goes through like a cubic, but goes through. And then I do get the end behavior I'm expecting. And then this is why this is easy. Greater than 0, where am I looking for? Values above or below? Above. So I highlight this. These are the outputs that are greater than 0. I need the inputs that create it. So it's those. So it's negative infinity to half. I told you today's homework was going to be easy. And that's why we did that quiz is just to get all the things that we need to do in order to be ready for today. Part of it was knowing the polynomial dance, and all that. I am going to do this one because this does have a special condition and is related to what I told you about with the difference of cubes in the quiz is. Okay, so just remember that I said that about this one. And I'm glad this is here because this is 0 as a 0. People miss this all the time. Then I'm going to skip to this. What's x squared minus 4? X what? X what? Minus 2 plus 2, right? And for purposes of speed, you could do that real quick and just replace that so that 2 and negative 2 are zeros. 2 and negative 2, and put them in relation where they are in a number line. Don't be a goofball. Don't put them out of order. Screws up everything. But wait a minute, what about this other one? What about this? I'll change colors just because it is really different. What kind of zeros do you get for that? Imaginary. These are I numbers. This is root 3. You take the square root of negative 3. It's negative, or no, it's plus or minus I root 3. What does that mean as far as x-intercepts? Are there any for this? No. So that doesn't apply to answering this inequality. Are we paying attention over there? Got a lot of paper flipping over there. Okay, so here's what happens with this. I don't know where it occurs. I couldn't care less. But what you're going to get for this I number 0 is another extra flip somewhere, but it never turns into an x-intercept. So wait a minute, I almost went out of order here. What is this if I multiply it out? X to the what? 5th. And then what's the leading coefficient specifically? Are you paying attention over there? No, you're not. Okay, what's the leading degree? What's the leading term? Negative 2. Licking the walls over there. Okay, so now this is supposed to look like this. Like that. Okay, so I'm supposed to know that. Okay, so what about this I number 0? This is what happens. There might be another little crinkle in there somewhere, but it doesn't necessarily have to be there. It could be an extra crinkle in here. It's irrelevant. All these other zeros, I don't care if the extra crinkle was in here. It doesn't matter. The extra wrinkle in the graph is somewhere that does not affect above or below. Got it? So you don't even have to incorporate that. I'm just doing something so you understand that's what occurs. I don't know where it's at, and I don't care. And nor should you. Okay? So anyway, back. Someone asked me, how'd you know it was up there? I'm going to flip my lid. All right? Okay, that's the non-listening wall licker. Where am I looking at? Above or below? Above or below? Below, actually. I heard someone say above. And I think that's it, right? I just don't want to make a mistake there. Wrong! What did I do wrong, everyone? Brackets. Sorry, I got distracted. I thought someone was, And then 2 to infinity. Never brackets on infinity or negative infinity. Never. Okay, let's see if I have to do this one. Oh gosh, what time are we at right now? How many do we have? 7 minutes? I don't know. You subtract, and then that's easier than maybe this one. Let's go ahead and do this. I don't know. They're both pretty easy. X to the 4th. I got to get to the next page. Minus 6x squared. I shouldn't even be doing this one. And then you actually have to factor. You take out an x squared, and then you got to, okay, then that would be x squared minus 5x minus 6. What multiplies a negative 6 and adds to negative 5? What's the answer to that? What multiplies a negative 6 and adds to negative 5? Negative 6 and what? 1. And then this turns into, I'll just do the graph. You should know what the answers are after this. So this would be at 0. Don't screw that up. I told you. And then this is negative 1. And then this is 6, just somewhere out there. You don't have to be like real great on your spacing. Doesn't really matter to the question. And by golly, it is an x to the 4th. So I should know it goes like this. So then what happens is it goes through this 0, bounces at this 0, and then goes through. That's why we did that bell work in the first quizzes part, the first questions. We got to know what those zeros do at those spots. So that's why I did that. And then I'll highlight, but then that's it. It is greater than or equal to 0, so we're above and on and above. Okay, got it? So we have to say 0 is a 0 as well. Got it? Okay, I got to move on now. I don't want to, go to the bell here. Okay, and then really the real good one is, why are you putting your stuff away? You got 5 minutes. Okay, what are you doing? Shuffling his papers around here. Okay, I pull out an x squared, and then I have 2x cubed minus 8x squared minus 8x plus 32. Wrong. What should I have pulled out? 2x cubed. That would have made my factoring easier. My bad, dogs. And then this is 4x squared, 4x, and then 16. Now you get lucky on this. You get real lucky. Because look on the inside. Is that factorable? Is the inside factorable? Absolutely. It's a grouper. Okay? Grouper. Anyone ever have that? It's delicious. So I'll group this. And then this. Sorry. And then x squared. And then x minus 4. And then take out a -4. Look at my structure. See that plus sign in the middle? Just yelled at my regulars today. We were doing some factoring on the board and just don't like that structure when you don't have a plus in the middle, because that's what really should be happening. Then x minus 4 bracket, and then one more factoring. Actually, a couple more. I'll go back to parentheses. You pull this x minus 4 out, and then you're left with x squared minus 4. By the way, what is x squared minus 4? We already had this. X minus 2, x plus 2. No time. Just squeeze it in right there and then cross it off so that you know what, that I got that done. I don't mind you doing that, by the way, for showing work. We want to be efficient. I told you that. 0, just be careful. That's a multiplicity 2, and then 4, and then 2 and -2. And then I look at the original. The original is an x to the 5th positive, so it should be like this, at least for the ends. So it should go through, bounce, through, and then through. Sorry, that's a real quick graph on that. Less than, where am I looking, above or below? Below. Not even including that 0, so it's just below and below. Doesn't have an equal sign, so I could skip through that 0. Right there as being a 0. So it's -infinity to -2 and then 2 to 4. And in our last minutes, I know the bell's going to ring if you want to watch. This is what the other hour did. This one is not factorable. So when it's not factorable, we got to do the synthetic division testing thing. Okay, and then maybe a P over Q list. But watch how nice we are. 1, 4, 1, -6. Okay, so it's all the factors of 6. 1, -1, 2, -3. Let's try 1. Watch how nice we are. 1 times 1 is 1. 1 plus 4 is 5. 1 times 5 is 5. 5 plus 1 is 6. 1 times 6 is 6. 6 plus -6 is 0. There's one of my zeros. Hey, everyone. No one got this right in the other hour. What multiplies to 6 and adds to be 5? I just heard it already. I heard someone say it. 3. It's not 6 and 1. It's 2 and 3. So now I'm factoring this. This is x plus 3, x plus 2. So here are my zeros. 1, -2, -3. Okay, that's how I get those done if it's not factorable stuff that we already know how to do. All right, and then this is an x cubed, so it goes like this, through, and through. I'm just trying to miss my zeros so I don't mess them up, and I'm looking for above. So to actually finish this off, it's from -3 to -2, union that with 1 to infinity. Oh yeah, the bell rang. That is perfect timing. That felt great.